Here we go, problem 4-94. Solve each of the following inequalities. Express the solutions algebraically and on a number line. Letter A, 3 times the quantity of x plus 2 is greater than 4x minus 7. We're just going to solve this algebraically like it's an equation. So the first thing we need to do, we have x's on each side. We're going to have to get them all to the same side, which will require us to distribute our 3 through here to get the x out of the grouping symbols first. So 3 times x gives us 3x. 3 times positive 2 would be 6. So we have 3x plus 6 is greater than 4x minus 7. So I need to get all my variables over the same side, or keep it balanced here. So if I have 3x's over here and 4x's over here, I'm going to take away 3x's from each side to keep my coefficient of my variable positive. So I have 6 is greater than x minus 7. Well, what number minus 7 gives you 6? That number should be 13, and we get that when we undo it by adding 7 to each side. So we get 13 is greater than x. Or if you're more comfortable, you could rewrite it the other way and say x is less than 13. So this is our answer represented here algebraically. And we will check it and put it on our number line here, this next part. So let's put our number line on here. Now if it's me, I put my 13 right in the dead center here. So that is my boundary point. Remember, when x is by itself here and we've got it equal to some numeral, that is typically going to be our boundary point. So it does not equal 13, so we're going to use an open circle. And let's mark the right side as 14, and let's use the left side to be 12. And if you're not sure which way to go, just choose a value, plug it in to see which one makes it true. If I chose 12 and I plug it in for x, I say 12 less than 13. Is 12 less than 13? Yes, it is. That is true, which means that if we took it here, we'd be talking about all the values less than 13 over here. Now, if you want to check it even, do a better job checking, is take it and plug it back into the original inequality here to make sure that it makes that true. If I said 3 times 12 plus 2 is greater than 4 times 12 minus 7, this would be 3 times 14, which is 42. I say 42 is greater than 4 times 12 is 48 minus 7, that would be 41. So this holds true. That is the correct solution. So this is algebraically, this is graphing. Letter B. 3x squared minus 4x plus 2 is less than or equal to x squared plus x plus 6. Being that this is quadratic, or it appears to be quadratic, let's go ahead and try to set it equal to 0. I'm going to go ahead and take away an x squared from each side. This should leave us with 2x squared minus 4x plus 2 is less than or equal to x plus 6. I'm going to kill 2 birds with 1 stone here by, not that I don't really kill birds, okay? Don't start rumors. But I'm going to take this here and I'm going to do 2 steps at once just to save some time. So I'm subtracting an x from each side and I'm subtracting a 6 from each side, so that I'm going to end up with 0 over here. And I'll have a 2x squared. Negative 4x minus x is going to be negative 5x, and then 2 minus 6 would be negative 4. Our next step would be to solve this by factoring if possible. And I already know that this will not work with factoring. So if factoring does not work, we can go ahead and try our quadratic formula. So for those of you that forgot it, hopefully you didn't, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So a in this case would be 2, b would be negative 5, and c would be negative 4. Let's take them and plug them in. So x equals the opposite of negative 5 plus or minus negative 5 squared minus 4 times 2 times negative 4 all over 2 times 2. So I've taken and we plug it into the quadratic formula. This is going to help us to figure out where those x-intercepts are. So the opposite of negative 5 is 5 plus or minus. Negative 5 squared would be 25. We've got plus 32 all over 4. See if that simplifies for us. 25 plus 32 is going to be 57. So we're going to have 5 plus or minus radical 57 all over 4. So what we have to think about now is this. This is two coordinates here. This is 5 plus radical 57 over 4 and 5 minus radical 57 over 4. So that would be like that point. The second point would be 5 minus radical 57 all over 4. Different 4s. I don't know why I do that, but this one's cool and so is this one. So now, if you want, you can use your calculator to come up with those values. You would end up with, I'm actually computing them off here right now. You'd end up with approximately 3.13. That's rounded. And you would also have approximately negative 0.64. Negative 0.64 as your second solution there. Now, when we take these here, if we want to put this on our number line, remember we're looking for the x values. So let's put this on our number line. Negative 6/10 is less than 3.13. So let's do negative 0.64. And we have 3.13. These are our boundary points. These are very important here. You notice that we kind of got away from the fact that this was an inequality. But if this is going to be less than or equal to 0, I know each of these would be a solution to the inequality. But what do you do next? Is it going to be shaded in here? Is it going to be shaded on the outsides? We have to figure out where are the solutions. So we've got our two boundary points. Now what we need to do is we need to take values and test. So let's just kind of check this off. We found our boundary points. Okay, so we found our boundary points. Now we need to check the regions for solutions. And what does that mean? Well, I'm going to check this region here. I'm going to check this region here, and I'm going to check this region here to see which of them gives me a true statement. So first thing you can do here is find a value that, you know, fits over here. In this case, I could say, all right, I'm going to try -1. I'm going to try 0. That's an easy one to work with. And then I'm going to probably try, let's say, 4. Let's take them. Let's plug them into our inequality here to see which of those values makes it true. So the first one, let's do, and I'm going to plug it into my original one at the very, very top. So I'm going to say, let's start with -1. We're going to say 3 times -1 squared minus 4 times -1 plus 2. That should be less than or equal to -1 squared plus -1 plus 6. I'll move it down here a touch. And just simplify each side there. You can do this on your calculator if you want. That's fine. -1 squared is 1. So I have 3. -4 times -1 would be plus 4 plus 2. That's going to give you 9. -1 squared is 1. We have 1 minus 1, or plus a -1, plus 6. 1 minus 1 is 0, plus 6 is 6. Is 9 less than or equal to 6? That's a false statement, so that means that -1 is not going to be our solution. But chances are then that 4 is probably not going to work either, but let's try 0 first. So for 0, we've got 3 times 0 squared minus 4 times 0 plus 2 is going to be less than or equal to 0 squared plus 0 plus 6. 0 squared is 0 times 3 is 0. Then we have 0 minus 0 plus 2. Over here, we're going to end up with 0 plus 0 plus 6. And then 2 is less than or equal to 6. That is a true statement there. So since 0 works, that means it's part of that solution set. So we're going to have that answer right there. We could try our 4 then, but 4 probably will not work because it didn't work on this side. So what we have here is a conjunction. So we have our graphical solution. We just need to write it algebraically. So what I would think about is this. We had 5 plus radical 57 over 4. Remember, that was our 3.13. What's this inequality here? Notice it's going backwards here. So we're going to say x is going to be greater than or equal to one of the values, and it's going to be less than or equal to the other values. As long as you set this up correctly and both of these are going the same direction, you can write an and statement this way. We're going to write -0.64 and 3.13. These are the approximated answers because I rounded. If you're using the actual answers or the exact answers, we'd want to put these values in instead of our decimals. That is the algebraic answer for this one. This is the number line answer for this one. If you have questions, make sure you ask your teacher. This is problem 4-94. Hope this helped. Have a good night.